Cool. All right. All right. So I'm gonna wing this a little bit. So I think it's gonna be two things, right? The Elasticsearch a little bit, right? I'm not gonna go through the whole presentation that I've done in Elasticon. Probably just the last part, which might be interesting to how do we get performance out of this thing. And I think some wanted to know about our deployment on using LXC and Docker and Ansible, all kind of stuff. So I'm going to kind of go back and forth on this. So that was just like the title slide that, when I went to Elasticon. I believe this is available online. I haven't watched the video.
You didn't put your full title on there? Just a comma engineer?
Yeah. You know how it goes. Not in marketing. Cool, but anyway, so I talked a little bit in that presentation about Cox and what we do, and also put this, because it was during the Olympics, I put we kind of did this Olympic stuff on the CDN. And I also talked a little bit about traffic control, about all the components, but I'm going to skip through this, right? And talked a little bit about our CDN team and what we did, and LXC and Docker's on there. And traffic control, all right. And what traffic portal looks like, and this is when I usually start. So I kind of talked a little bit because it was Elasticon. It's like, hey, we've been using Splunk, right? And our logs at the time were kind of exploding, and it would cost a lot of money. So we basically needed a new logging platform. This was like kind of the story of the CDN, how we ramped up our traffic within like about a year. We went from 0 to 1.5 terabyte. I think that's in 9 months or so. Basically because of the X1 syndication. And we had some issues with Splunk about slowing down reports, like trying to search for stuff, and getting slower and slower. And basically because our platform is kind of shared with everybody else, and everybody put their data in, and they all have their little rule. And when you run in smart mode, then it crawls down to pretty slow speed. So that time we actually went through a proof of concept. Basically I was running Elasticsearch in the lab to ingest our production data. So this is the pipeline we had at the time. So on our edge and mids, we have, actually 2016, I think that's when they came out with FileBeat, right? And something before we were going back and forth. What was the stuff that you guys were using at the time? It was like a Go program. Eka, yeah.
Heka was discontinued, and then there wasn't anything.
Yeah.
FileBeat came along.
Yeah, exactly. I tried to use Heka. It was kind of a little bit cryptic, and didn't do what I wanted. And somehow FileBeat came along, and that just kind of made it easy to ship to. So at the time, we were actually sending from FileBeat to Logstash, right? Because they didn't have the Kafka output at the time, I think. And I was actually outputting Logstash, once it's parsed into I'm going to say it wrong. It's like Redis or Redis.
Redis.
There you go. It's like React or React. So we're putting this in this Redis queue. We had like 2 of them. And of course, I just brought it up by default. So it's basically in memory only. It doesn't persist to disk. And I know Jan loves Redis, right?
Used to.
Used to? Used to hate it after, right?
Then they all said I couldn't do it anymore.
Yeah. And the issue that
You love going in and backfilling all the data when it fell over.
Yeah.
It served a purpose for a while there. Come on.
And at the beginning, so Redis, it's actually using a lot of memory, and there's no limit, right? So basically, we were running this into LXC containers. It ended up kind of causing a bunch of OMs on our other processes that were running in the same box. And then learned real quick that you got to specify memory limit in Redis, so it doesn't do that. And then we would actually pick up the log from Redis in the lab through Logstash and ship it to Elasticsearch. At the time, I think we had about 4 nodes in the lab to ingest the production data, and that was kind of fine. I think we ran this thing in the lab for about a year until we moved to our current logging pipelines. It's about the same, although we actually are shipping our logs from edge mids and traffic routers and using FileBeat, and we push them to Kafka. So it's pretty standard to what everybody's kind of doing. And we're using these retention policies, making sure we're not running out of disk space, which we did a few times. And we're also running replicas just in case that one node decided to bail out. which happened a few times in the past. But we have a few Logstash that we call our Logstash indexer, which takes the data from Kafka, parses it a little bit, right, from the raw logs, and actually output JSON into Elasticsearch. And we also had this thing called the Kafka Stream Aggregator, and I presented that stuff, I think, when we were in Atlanta. Yeah. I think it's like
So what does Logstash do here, Steve?
Logstash is like, so basically multiple input, multiple output is really basically the same thing as Heka, right? Although it's primarily made to ship data to Elasticsearch, right? But it's not just that. So it can actually connect to Redis or Kafka, or it can actually, like the file beat can actually output directly to Logstash. And you can output to Elasticsearch, you can output to Kafka, you can output about everything you need. You can actually output AWS as well, I think. So I know that you guys were working on some analytics stuff.
Getting it to perform.
Okay.
Yeah, so
Yeah.
It depends on your.
just out of curiosity, like to know what scale is necessary for performance. Like can you tell us how many edges you have, and then how many nodes you need for Kafka, and how many nodes you need for Logstash and Elasticsearch?
Yeah, so it's going to be on the small side, but so we have,
What the ratio is.
yeah, I got about 150 edge caches, mid caches, right?
How many?
So I've got about 6 instances of Logstash that picks up the data from Kafka. At peak, they run pretty hot, right? And I think I've got some graph from after this. So the issue with Logstash is if it takes the raw input logs like we have today, right? The problem is to parse it, right? But if we can actually put JSON in the Kafka queue directly for Logstash to pick it up, then you get like a 2-3 times performance. So we're running this on pretty old machines. They're like 5-year-old R720s. We've got about 12 cores per. And I think I just dedicate like 4 cores to Logstash. But with the raw logs, they'll do about 10 to 15,000 messages per second, right? If I go JSON, it's more like in the 30 to 40,000 on these old machines. So if we put on newer machine, it actually performs a little bit better.
You said you dedicate cores on the edge, so your Logstashes are running on your edges?
No, Logstash is running centrally, right? So we have 720s that are, I'm going to talk a little bit about this LXC and Docker stuff, but we have these 720s that are virtual kind of hosts that we manage, right? We don't use any of the cloud stuff that we got at Cox, if there is.
But from a high level, it's sounding like you're needing about a Logstash every 40 caches or so.
Probably, yeah. It depends on the load, right?
And assuming it's scalable.
Yeah, and I mean, our caches, like, they don't go really across like 5 to 6 gig right now just because, we don't have enough traffic. So it's really a number of, I mean, if you're sending 40 gig out of a cache, I mean, I'm assuming, just shipping the data is going to be a lot of CPU usage, but somehow it needs to be processed. So, I mean, you could ship directly from the edge to Elastic if you wanted to, if you had the right plugins. For example, if you have FileBeat and you want to do some processing at the edge instead, right, and replace FileBeat, or maybe put a plugin, in FileBeat to pre-process the ATS log, like they're doing for, I guess, Apache HTTP and all that kind of stuff. Now they can actually do something about it.
But then you have to scale Elasticsearch to the same level, right?
Yeah, exactly. Yeah, but the thing's like if you actually pre-process at the edge and then still ship it to Kafka, and you don't have to redo this centrally, I mean, you're saving a lot of CPU times, like in that area at least. If Logstash just has to pick up the log from like the JSON formatted log already from Kafka and ship it to Elasticsearch, I mean, you're saving a lot of CPU right there.
I'm trying to think about how that.
So, about what? Which piece?
Your Logstash index.
Logstash. Yeah.
That are on there.
Yeah.
Is there any sort of what if one of those?
Oh yeah, look at that. I forgot an S.
One of those falls over. Like I assume it's.
Yeah, the other one's going to pick it up.
Logstash is configured to talk to certain Kafka brokers.
So, all right. So that's so let's say we run about I think we got 16 partition right now. It's just because we don't have that much data, right? But every Logstash, is configured to read from different topics, right? And you also have to tell them you can only connect to like 2 partition at most, or 3 or 4, right? And that's something that you got to tell Logstash. If you've got 16 partition and you got 8 Logstash, you want each of the Logstash to connect to 2 partition.
Then one falls over.
Then the other one's going to pick it up. Like one partition's going to get empty, it's going to get off of it and connect to the other one. It's going to go back and forth.
I guess I'm trying in my we're not doing something like this and we're trying to write our own code.
Because we couldn't get it to scale, but maybe it's because of the JSON thing.
Yeah.
We were literally running hundreds of instances of Logstash and still couldn't keep up.
Yeah. I mean, if you run this thing in OpenStack, and it depends on your CPU speed and which kind of filtering you're doing into it.
Oh, that's the other thing is you got off. You're on real hardware.
Yes.
For our scale, it looks like we would need hundreds of blocks.
Yeah, and it just didn't.
Yeah, but if you, it's better to ship it in the right form. So.
So, I mean, I think it depends on speed, and it also depends on the Elasticsearch that's receiving at the other end. If you've got delays there, I mean, your Logstash will seem to use more CPU and do less.
Yeah.
So, all right. So, how we deploy Elasticsearch? So we've got these, 720s that we got today. We basically install Docker engine on it, and we just start these containers on all of them, right? And it's actually managed through Ansible. This is like a playbook, right? It's one of the tasks into a playbook. And the great thing about Docker, at least if it's done right, is that you don't have to supply a configuration file anymore. All you do is specify these environment variables. So I think it's a pretty good thing. Like the deployment that we were doing before, we were actually deploying with Ansible using the RPMs, and we had to generate all the template, but take care of a whole bunch of things that relates to Java and everything. But with these Docker images, they all take care of it, in the Docker image, so you don't need to deal with this anymore. And it's also the way that Elasticsearch, like they have this Elastic Cloud Enterprise. That's how they actually deploy now. They use just their Docker image and then just deploy it with their own orchestration system. So this makes it easy. I mean, before upgrading Elasticsearch, I think we had like 5 or 10 nodes before, and it would sometimes takes multiple days to go through them and upgrade. And the last upgrade we've done from a 5.6 release to like the 6.2.4, I think that was done last week. I think it took our guy to do it in about 2 hours for like 15 nodes. So when I started this, we had like a 5 physical server. We had a lot of memory on it, and we were running like a single node per server, and we had these 1.8 terabyte hard drives, and that was fairly slow. We then upgraded like to 10 physical server. It's the same server, the same R720s. Although we were running about 3 nodes per server, so 3 instances of Elasticsearch per server, and we were like pinning the CPUs to them. So if we had 12 CPUs, I would give like 4 to each, so they don't compete with each other. And we had like 3 2 terabyte SSDs. I guess at first, it was like kind of 6, but so we assigned 1 SSD per instance, right? So just through mounts. That was working kind of okay. I thought the performance was much better, but then we're running in this mode where we run 2 instances of Elasticsearch now, but one is actually mapped to a TMPFS, right? Like kind of same thing we're doing with ATS, but this one you can actually just use TMPFS just because it's easier than the RAM disk. And then one node's all on these SSDs. So what we do is that we send our indexing all to the hot nodes, right? So we index in RAM, and then we ship this data back to SSDs. I think after like 3 hours or so. It's like a job that we run in the background with Curator that it just dumps whatever is in RAM to SSDs. Now it actually helps with the wear level in SSDs because it's not constantly writing. But I mean, I don't know who cares about this stuff, but we kind of do this. Yeah.
So in order to get this to where it is today, did you have to really dig deep into optimizing Elasticsearch and?
Nah, not really. I mean, with time, all these optimization, they just kind of came through like Elasticsearch. I mean, they've been working really hard in the past 2 years to make it easy for people, right? And as soon as you get onto this Docker thing, right, it makes everything easy once you understand it. And so far we've been running in Docker for, I'd say probably the past 6 to 9 months, right? And I mean, we don't need to take care of it much. I mean, it just kind of works.
What's the ratio to the actual raw log data versus the summarized data?
So that's one part where Elasticsearch is not really efficient, right? And I think it's kind of a one-to-one because we're running with a replica, right? And you have to. I mean, if you're going to do some sort of maintenance, you have to have a replica. It's much easier.
Right.
And it's about one-to-one. I mean, it's supposed to compress this data and all that kind of stuff, but
I'm assuming you're filtering some of the details from the raw logs before you pump it into?
I don't at this time, no.
Okay, so it's just a conversion from the actual raw logs
Yeah.
based on format that you're pulling in, and you're not seeing any sort of performance issues.
No.
What sort of data throughput are you seeing on a daily basis?
So we're putting about, I think it's like 2 to 3 terabyte in it, right, with the replica. But I mean, throughput. I mean, we haven't measured.
2 to 3 terabytes a day.
Yeah, which is it's not much right now, but yeah. I mean, we're not like Myriad stuff is not going in there, right? So, one thing that we've been doing with Splunk is that, and I don't know if I'm going to do this at all with this, or we're just going to put everything in there. Is that we actually filter all the 200 status code, right? And we just send the errors to Splunk so we can actually alarm on thresholds, like when something bad happens. So.
Are you doing it on the caches?
Yeah. So we actually installed the heavy Splunk.
The same exact thing at Rutgers.
Yeah, and I mean it's pretty nice just because we actually have all the templates and Ansible playbooks and we just deploy them. So, but yeah, a change takes about like 5 seconds.
Jared's right now.
Yeah. So anyway, so this SSD, the RAM stuff, and SSD's been working pretty good. I think that I don't see much benefit of the RAM disk in production because my servers are slow, right? But when I ran this stuff in the lab, a single node in RAM, I could do about 100,000 indexing requests per second. And I think this, I think this graph here is actually an R730 that I ran it on. And you can see here the progression here. So I was actually sending like 30,000 events, and I brought up another log stash, right? And then it ramped up and ramped up. So I could index like the whole production, my whole production on these 10 machines I was doing on a single machine in the lab. So that's how the difference was with like a faster processor and sending it to RAM. And I've been testing something else. These Intel P4800X. They're like these NVMe's PCI Express cards. Dell didn't want me to order them because they told me that they wouldn't work on the servers, but we did anyway. And the old service is just fine as long as you don't boot from them. You're okay. But then the performance are pretty good. It's about under 10 microsecond for writes and reads. I tested. I think it's like 2 gigabyte per second read and write. And the impressive number is just number of IOPS. I mean, writing to RAM or writing to these devices, was about the same performance. So I'm sure for cache it'd be great as well. I wish ATS would support like this tier caching, so we could actually put the RAM cache on these devices instead of RAM, right? So we could have like larger, RAM caches, but so somehow I broke production one night for Elasticsearch, and you can see here on the left, that was our indexing rate, and somehow this broke here. I don't remember what happened there, but when I restarted it, it re-indexed like 100,000 requests per second until it caught up. In the past, this would have taken maybe 4 or 5 hours if you go directly to SSDs, but it recovered pretty quickly. And it was running 6 logstash instances, and that's using the raw logs. So talked about improving our pipeline efficiency. The first bullet here is that what you guys have seen is lower logstash, CPU usage. It goes pretty crazy, right? The problem with FileBeat. If you want to do the same filtering we're doing in Splunk, for example, you can't really do it, right? As the format that is right now in ATS, because you can filter out based on the regex and all that kind of stuff. But and you see at the bottom, that's one of these raw requests. So one thing I'd like to do, and I already have all this pretty much together, but we're going to create these JSON log files instead from ATS on disk. And then FileBeat is able to read in JSON natively, and we're going to be able to do this kind of same filtering that we were doing.
But you filter at the edge as well? You don't send everything to Kafka?
Well, today we filter based on regex, right, for FileBeat, so we do have these includes. Just because we were kind of scaling this thing up, then we didn't want everything to go in there. Now we're actually putting more include line, and now we're going to go to exclude line. But once we got the JSON stuff, then we can actually like do more parsing inside of FileBeat and making decisions based on integers and that kind of stuff, like status codes and.
But if you're sending everything to Elasticsearch, do you really want to do all that filtering still?
Well, you never know what happens, right? And I mean, there might be these new services that goes crazy, like Myriad, that's got like 30,000 requests per second of 404s, and you don't really care about it, right? So.
Yeah, we send everything into Kafka.
Yeah.
So everything doesn't matter if it's everything goes.
Yeah, today we don't, and that's because we still have these scripts that runs at the edge that will actually ship the raw logs to a log server somewhere instead of picking up from Kafka. And it's just because we haven't spent the time on that.
You could take a raw log somewhere else as well.
Yeah. And I mean, we want to use Kafka to do this kind of thing because we can actually filter and do all this, funny stuff after. But we just haven't spent the time to do it. And there's no requirement since we don't have, external tenants that we need to send logs to at this time. And that was just like some example of dashboard, that we had. Basically, we're using Grafana, but I had to put Kibana out there because, we're at Elasticsearch. But look at the bottom graph here. Right? These are average DTMS, right, by region, right? And there's a lot of difference here, right? And it's kind of funny how this one here, it's all CentOS 7 and SSDs, right? And the one at the top here, they're actually the R7. This is on CentOS 6.
That's a 532 ATS?
Yeah. And
It just
somehow
works,
in the
right?
middle,
It just works, right?
yeah. And somehow in the middle, we got Cache Group that's got nodes with SSDs and nodes with, some CentOS 6 and some CentOS 7 mix. So right now, if you look at all our caches, like it's all hovering around the 40 millisecond mark.
Except for those 532 caches.
No, these 532 that's it. They're all 532s. Yeah. Sorry, it's CentOS 6, CentOS 7 difference.
You're running 532 on 7.
Yeah. One of your build.
Hardware is exactly the same. Hardware is exactly the same between CentOS 6 and CentOS 7.
Yeah.
It's all 730s or
So we have a mix. So our OTT CDN is on 720s, the older stuff, that we started with. And then the rest of them is all 730s. I think we got the 1.2 terabyte drive on those. That's the first 64 cache we installed. And then we moved into the 630s with SSDs and the 4 terabyte drive, which gave us like the same amount of cache, like about 30 terabyte per box. It was just like 1 RU instead of 2. And this year we're going to install the 640s. It's basically the same thing.
Are you only using those for your delivery services, or you're running all the delivery services across those SSD boxes?
Yeah, all delivery services. Yeah, and there's a huge difference between SSDs and hard drive. I mean,
I'm sure.
yeah, but the one thing's like last year when we installed the 630s, we actually used the SATA DOM thing. So it's really like it gives us not a lot of space, like 64 gig for the OS. So I mean, if we don't ship the logs out of there, I mean, it grows up pretty quick. But this year we actually went to the boss card. So it's like NVMe drives or M2 onto like the rig, like a different PCI card that's in there. So they actually give better performance than hard drive and the SATA DOM. All right, so that's it for Elasticsearch. You guys have any question about this RAM disk stuff, or I mean, that was mainly the thing about how to increase the performance about Elasticsearch is just use the RAM disk. And the faster CPU you get, the better performance you're getting off the RAM disk. Cool. All right, and let's see this here. All right, so yesterday someone wanted to know about this LXC Docker stuff we're doing. Here's how we deploy stuff at Cox here. So we have caches on bare metal. All the control plane, which is called like Kafka and FluxDB, traffic control, everything else, right? Everything is actually it was into plain LXC containers, right? So we actually manage our own virtual host, and we actually installed LXC containers, and I'll go a little bit in detail. We have stuff that's actually in Docker, and we have stuff that's actually in Docker within LXC. And Elasticsearch is all in bare metal, but in Docker containers. So why did we pick LXC to go and start with? So we didn't want to go KVM into VMs, and we had some performance issues when we tried to do the stuff in our central VMware in containers. Not containers, but virtual hosting. So what we get from it is basically bare metal processing speed. It's basically the same kernel. You create a container, you're actually just interacting between the process and the kernel. So there's no hypervisor in between. You can actually limit the resources if needed, CPU shares and memory. It's a little bit cryptic on how you do it, but it's possible. So you want to limit some application for, to not use more than 8 gig of memory or something. And what LXC gives us is this network namespace, which is something that, with Docker you can't get. And maybe you can get, but LXC, it's like installing a KVM, for example, it's the same thing as creating a VM. You actually install the OS through templates, and it's actually basically installing RPMs into a different directory. And then it starts the container with that rootfs. Okay? And the great thing about it is like support IPv4 and IPv6, right? It's just a bridge interface. It owns the network inside. We can also manage IP tables. It comes with some drawbacks that we had some issues with. For example, we couldn't install HTTPD into a container, right? And it's just because the way it was actually wanted to install some of the files was not really compatible with the C groups and all the stuff that these containers are going to. So you can't configure the CTLs either. So you've got to configure it on the host. So if you need to increase number of file descriptors and all these kind of things, you have to do it on the host level. And for example, if you want to use FTP, somehow we're using FTP. So you got to install the contract module at the host level before you create a container. And OOMs, when I was talking earlier about Redis, so if you've got a leaky process or something that uses a lot of memory, it might kill other processes that's running on the same machine. So try to, yeah.
If you set up the filters so that something that only has 8 gig of memory, can it still kill the other processes?
So it's basically a soft limit, right? So I think there's like a soft limit and kind of a hard limit that goes to it, but I believe it limits from making any new memory calls, like to get more memory. So I think that solves this problem. But you still got to be careful about, well, if I've got only 64 gig of memory, like how many of these processes with limits can I run? You might still be oversubscribed and you don't know about it. All right, so I put this little diagram together this morning. Hopefully it kind of does the job. But so we have these machines called VHSTs, right? They're bare metal. And then you can run LXC. Each one of them is like LXC containers, right? So, and they have their own host names and IP space. And some that we just do LXC, the one in metal, for example, well, we load CentOS 7 on it, and we install traffic router, telegraph file beat, right? It's like you're managing a VM or bare metal host once you're in there. So on the left end, we can actually install Docker engine with an LXC, right? And now I can actually run my containers inside, and I can actually manage my IP table at the LXC level. Huh?
Containers and containers?
Yeah.
It's
It's just
Daisy chaining power strips too.
Yeah. But I mean, it doesn't care because actually, like, it ties into the kernel directly. I mean, it's not like there's overhead, right? So, but then you can actually create containers within the LXC containers, and at the host level, you don't see those containers. I mean, if you do Docker PS, for example, so it isolates them. But you have to give it access to var lib Docker or something like this, so we can actually read from the socket and make sure it can create all the stuff. But it's kind of nice because you can actually have your Docker containers running on a host name with IP tables, right? And you can do your own security in there. So I find it kind of useful to be able to deploy stuff.
So
like
the
this.
whole advantage here is like you basically have a way to manage the OS.
Yeah.
On the inside of the LXC container.
Yeah.
And then you put your Docker.
Yeah.
Containers inside.
Yeah. And the funny thing too is that on these VHST, we actually run Docker engine on the host as well, right? Well, you have to, I think, to be able to use an LXC. But and then you can run other containers there. I mean, it's kind of hacky a little bit. I mean, all these things works together. We can actually throw in KVM right on the side because it actually works as well.
Do you really have in production a box, a bare metal box that's running traffic router and InfluxDB
Yes.
on the same box?
We have multiple of these things. I mean, if you look at the CPU usage, I mean, as long as Logstash is not running in the same one, you're good. Or traffic monitor go line. I don't know. So that's right. So this thing here where it actually attaches to a bridge, right? So we have multiple bridge on each boxes that's connected to different VLANs. And the host, of course, is connected to one of these bridges, got an IP address. So this Docker engine on the right will connect to the host, I guess, IP or network stack. But these LXCs will actually connect it to the bridge, and you get your own IP.
And on the network side, you just have all these VLANs configured to
Yeah.
go to that interface.
Yeah, exactly. Yeah. And some are actually bonds and bridge, and you know.
What was your title again? Network intelligence, right?
Hey, I'm just trying different things, you know. It's like 1 gig's not enough. Let's get like 2 1 gigs, you know.
This gave me a headache.
This presentation is called "And the Kitchen Sink." Too.
Yeah. We do a lot of stuff that, you know, we then need to kind of clean up afterward. But I mean, it's been stable for the past like 3 or 4 years. I mean, how often do we play with this stuff, really? These LXC stuff, when's the last time we actually had to go and play with the template? I mean, once or twice and revisit like these capabilities, right? And all that kind of stuff. But
So was the motivation to use LXC the fact that you could actually control the OS, or was it?
well, so all right, we got
The
six.
networking?
So we got 6 machines, right? And now we have to load 50 different components that all need their own host name. So what do? You load either KVM on these machines, but because you can't run all these packages, right? So now we're talking about like, well, we have 6 machines to do what 50 could do, right? And basically, it's like, you know, it's really a waste of CPU.
No. And LXC is not Docker because of IPv6.
So LXC, I mean, LXC is just a different thing. I mean, it came before or after Docker, I don't know where, but you know, we're still using the version 1 because that's the only one that they actually published for CentOS. But it's really like a VM, right? But you don't have an ISO image. So you've got a root FS.
Plus you don't have the Virt manager, and all that stuff too, right?
We could actually bring it up this way. So LXC supports
I mean,
Flipper.
that's how we're
Yeah.
doing it. We have KVM.
Yeah.
We're using KVM.
Yeah. But yeah, we use Virt Manager, and I just wish there would be a web version of this crap. I mean,
But compared to Docker, is there more capabilities?
Yeah, you get your own host name and your own IP address. Like
Yeah.
Docker, you don't necessarily have all that, right?
Yeah. At least not easily manageable, right? So Docker, you bring up a container, it's got a private IP inside, right?
Yeah.
And then you have to expose it to host. Now, how do you actually expose this externally if you've got 10 of these services that you have on the same machine, but they all run on the same port? Now you got to use aliases, right? And I think, who was doing this, Dan? Or yeah, yeah. So you got to put a bunch of aliases IP like on your box, and then you have to bind each of them, you know, manually. So this LXC thing, you just actually create a new container, and I think I've got an example of configuration file. I'll get there. So maybe that's going to be easier to understand. But it's basically it's a root FS image, right? Basically, it's like all the RPMs installed. It doesn't need a kernel because it's using the host kernel, and it just kind of starts it into whatever container stuff Linux uses. Yeah. So this thing here, so this is kind of describing a little bit the previous slide. So we have these VHSTs that we called, right? Just because it's the naming thing. They're running CentOS 7, so they're bare metal, of course. It could actually run into a VM too, but you know, I would not use that. We boot the system using custom ISOs, right? It's basically the same thing as Gen ISO, but we actually have a playbook for generating ISOs now. We don't use traffic ops anymore for this, and we actually do the same thing for our edge. But then, and that's the same process here. But so we configure the system. Of course, we got playbook for this as well, right? So we have the common roles like setting up users and DNS and whatever else we need to. sysctl modification, install the LXCs and all the tools, and we install this template to call these to create those LXC containers. And we configure the network bridges, and that's in the playbook as well, and IP tables. And then we actually can provision the LXC containers, and we also get the playbook for this stuff. So that's like the two ways that we kind of use to create containers. First one is you can actually just use the native LXC create. So you got to go and being root on the box and type this long command here, right? It's like, and you got to make sure that your configuration is proper, right? And you want to give it a name. You want to install it in LVM. So just a, and you, I think that's the block device, LVM. And then you tell it on which volume group you want to put it on, the file system type, so it's really inside LVM, size, and the -T over there, CentOS CDN, that's the template we're going to use, which release we're going to use, and where to take the yum repos configuration file, and then we give it an QDN as well. And once you type all this, I mean, a few seconds later, you've got the new container. And of course, you got to start. And then, so this, we kind of, I don't know if this is still long, but then we also have a playbook that takes care of going to traffic ops using dynamic inventory stuff that we got, right? It gets all the parameters, and it says, install it on this virtual host, but we want this container to be created, so it goes and get the information from traffic ops for this container. It writes this LXC configuration at the top, right? And we specify which bridge we want and the size. It will actually create a container, start it, right? And make sure it's network available, and then it's gonna get out. And we can also specify these variables like directly in host bars and Ansible, or get them directly from traffic ops. And at some point, I'd like to talk about this stuff about, we've been using Ansible dynamic inventory for a while, but the problem has been trying to get variables from traffic ops.
Like what kind of variables?
Like the bridge, right? Where can I put this information? I could put it in a profile, right? But then getting profiles is kind of not cool from an Ansible point of view, right? Directly from the API.
Get with me after. We've got a guy, Jonathan Gray, and he's doing that. And I don't know how he's doing that, but you guys should do that.
I know Dwayne was working on something, but I don't know if, does he get it on the spot or does he pre-generate everything?
I'm not sure. I think it's on the spot.
Yeah, okay.
No,
And
he actually is using that.
Okay. All right.
Yeah, I mean, we're doing,
I have to figure out what he's doing.
we're doing almost exactly that.
Yeah.
But with KVM.
Yeah.
For Rogers, we have Ansible playbooks, everything.
Yeah. And the problem we had is, like, for example, if we actually run against a cache, right, and we actually need to get parameters like, well, I want to know which disk I'm installing on, or, like on disk or something like this that we have to specify. The issue is getting profile parameters. Like, well, I have to get everything, right? I can't specify, give me this value, for example. So we have to get the whole profile table at this time, and now we got to parse through in Ansible with all the, I guess it's a list, you know, and then getting parameters is kind of a problem because the dual key thing. But I mean, we kind of worked it out, but it's kind of hacky. But yeah, I'd like to talk to you guys on how you can actually specify per host variables, right? So that's why these profile parameter, if we like server type parameter stuff, you know, and then, you know, by group, by host, by.
We've been overloading.
Yeah.
Overloading fields in the server.
I mean, the thing is right now, it's like, yeah, I mean, it's like, yo, you need something new, well, just create another column, right? But
Just let me shove some JSON in the comment.
Put it in the router host name, yeah.
yeah, yeah, we used that one for, I guess, the iDRACs before, because the iDRAC one didn't, we couldn't put like a host name in there instead of an IP. And if you guys want, I can go through this demo about like destroying a traffic monitor and just recreate it, right? Using these LXC commands. But basically, it's going through these commands here, like these playbooks. So I just put it. Oh, we can't see this.
Trevor can see it. I can see it.
You can see it. Oh, I see why. Okay, cool. All right, let me try that. Can you see it now?
Yep.
Awesome. Well, I can't see much here, but is it under the line? All right, cool. So the first command here would be like to delete that LXC container, right? The state absent, right? Just a standard Ansible thing. And then the next one would actually recreate this LIC container, and then because the template comes in and we have like a root password in there, we don't provision all the SSH keys. We did before, but then we need that bootstrap over there, and it does a few things. It actually sometimes set proxies because we have containers that lives on private space a lot, so we'd like to just go to proxies to be able to get all our RPMs and everything. And actually sets your user, install your public key in there, and then the next playbook is called CHS, but that's actually traffic monitor stuff.
That's Canadian, French Canadian.
Nah, that must be an Akamai thing. Yeah, I don't remember. It's like the Cox something server. Yeah, but we just limit to that host, and it's going to install everything and start it, and it's going to make it available. Yeah. Cool, and let's see here. If you want to see what these LXC configuration looks like, that's pretty fun. Right, that's basically at the bottom here. So you specify your IPv4, IPv6, the name, which that name here is the one that we specify when we launch LXC, right, the -n, right? And that's about it. And then we got these template. I think that, here you go. And I'm just going to put this there, but there's like different template that actually comes with LXC about, if you want to create a CentOS OS flavor, then you just specify the attached T CentOS. And we have this one CentOS CD, and it's just because it's ours, it's been modified for a few things. But yeah, it comes with all these. I mean, if you want to create Ubuntu or anything like this, off the box, it should just work. Yeah. And I didn't find this until I was way into this, and somehow I was like, man, this is difficult. And then I found this and like, oh, well, now this is all easy now. But it's basically bash scripts, that brings up the container. And it's pretty ugly, as far as I remember. I haven't been in there for a while, but it's a lot of, yeah.
Back to the 90s, guys.
Yep. So we just touched the part we needed to make it work, and that's about it.
Ooh, look at all those big comments.
Yeah, pretty cool, huh? That's what it takes to run a container. You don't need to understand it if it works, so. Cool. So we're not going to go through this. How am I doing on time here? Am I way past?
We're fine.
We're fine. Okay, cool. All right, is this going to come back? So this is just to show. So we've got Elasticsearch running in container. One actually has a name of SSD, and one's got a name of RAM. And this matches what we got in Elasticsearch as well. Just to show that we have two Elastic nodes running on every physical host, and they're bound to different ports, right? And they just join the cluster, and they're happy. And so this is just an example that we actually run cron jobs with Docker, right? And the cool thing about it is that I put this in bold, is that you can actually specify which version you want to run. If something is not compatible with Yad Curator, like version 5.2 or 5.4, but something is broken in between, then you need to run multiple versions, then you just run this Docker container and --rm, which remove it after. So, so it just runs when it needs to run. And there's a few things in there. So the delete actually is the one taking care of deleting our index after 10 days or 14 days. Roll just means that it's going to roll from RAM to SSD. And we have this rebalance stuff that we don't want to run at night. So we turn it off. There's some history there, but when you bring a new node in Elasticsearch, it might take days to rebalance, and you don't want to impact performance at night. Then we have these playbook. Well, apparently you guys are pretty well versed on Ansible now. So this one is the Elastic data. So we've got a few things at the top to tell Docker which kind of storage driver to use and which type. And once I actually do this inside of LXC, then I just want to use these the non-default one, but whatever brings me the most performance and less the space and all that kind of stuff for it. But then we, for Telegraph, I have this do a user mod to Docker to be able to read the Docker stats on the host, and we actually have these things. Well, for Elastic nodes, then we want to enable extra plugins for Telegraph. So we have a slew of basic one, but depending on the host type, we have different plugin that we want to use. And then we have all our standard roles, right? We install these Yum repo stuff, common user stuff, NTP, and this NTP stuff actually doesn't matter in LXC usually. And then we firewall is actually the IP tables and install Docker engine and install Telegraph. And then we can also run Elasticsearch containers based on all these variables. And actually we'll run, it's going to install the two of them based on some variables. And it's going to use like ports that's specified in the configuration file. But basically all this stuff that we had to do before was like all templates and install a bunch of files everywhere. Now it's like environment in a central location. Makes it much easier. I mean, it's still ugly, but makes it easier. And for example, that's like our playbook to install our InfluxDB nodes. Right? Then you're going to see the standard stuff at the top, but then the fun part is, you know, HAProxy, InfluxDB relay, and Influx, right? That runs on the same host. And it's going to install the templates and everything related to that. And that's just an example when we actually install this boot ISO.yaml, when we install an edge cache, mid cache, or VHSD, or an Elastic node. And we get this thing here, this iDRAC fact. And I think, is that open source? I think it's there somewhere, right? Yeah. That you can actually import for your playbooks. It will get some information from the iDRAC, but also probably reset password if it needs to be reset. Then we're going to generate this ISO, and then we're just going to call iDRAC boot ISO, which is going to load this ISO, and it's supposed to come back at the end with that everything is fine. But in that process takes about, I guess, 10 minutes on an edge cache to get it installed, like bare metal, rebooting and everything. So, and I threw this in, but we have a traffic stats Dockerfile that we plan to use in production at some point. It's still a pull request on our side, but and I don't know if you guys were using this to build Go programs, like so you do the from Golang as a builder, go get this, and it's going to build the binary, and then from builder, you can just copy it back into your CentOS7 container and get the rest of it.
Yeah, that's what I'm doing.
Yeah.
Steve, do you have any of this on Git at all?
I don't think so, no. I think this is kind of an internal, but, and I don't even know why I used CentOS7 here. But it could actually run from the same, I guess, Golang 183, or I don't think you need all that stuff anyway for Go, right? You can just run, I guess, from scratch. Yeah. So I think you can do like from scratch and just copy the binaries in the files, and that's it. So this one, of course, is not using environment to configure traffic stats, the CFG. That's the part that's kind of missing from this, where we don't need to specify a mount point to the stats file, but just specify environment variable for what it needs, right? And I don't know if you guys got this already kind of figured out, how to.
Some components can use environment variables.
Yeah.
Not all of them can, and,
Yeah.
and I believe that that's on Dan's radar.
Okay.
The stuff that he's working on for.
Yeah. So have you done some of this for traffic ops, for example? It's like you've got the script that basically reads environment and build a config? Yeah. Yeah.
Yeah, but is that maintained now officially, Dan, or
Well,
because
I'm
it,
working on getting
okay,
it in
because
shape.
it's kind of a lot of work to keep it
Yeah,
up
well,
to date, right?
what I'm planning on doing though is setting it up to bring up a full CDN with a containerized environment, and then using that as a test bed. So it'll actually do it automatically.
Yeah.
Bring it up automatically every build or every merge, and then.
It'd be awesome if we could actually build all the Docker containers for like release 2.2, right? Whenever it's GA, and maybe put it out there on Docker Hub or something. You know, just to kind of try it out, because I've got other system, like, you know, I'm trying other stuff in Kubernetes, for example, right? And I'd like to see if actually I can make this work and see what's missing and all that kind of crap.
That's what I'm working on.
Yeah. So, and this
And I'd
other.
like to get as much of this as I can get from people.
Yeah. And I mean, I can actually help with this one and, maybe make this one available. I'd like to get the image as small as possible because, I mean, the one I built for traffic ops, it was like 900 megabytes. I'm like, this is ridiculous. Right? And I'm sure we can narrow this down by using,
Just using Alpine instead of CentOS.
yeah,
Get you that from 200 meg down to
Yeah.
like 30.
exactly. So, yeah, okay. And that's about it. Yeah. Cool. Any questions about all this stuff or?
Yeah, would you be receptive to being a tester for Dan?
Yes.
For the stuff that he's working on?
Yeah, I mean, I've got a rancher kind of setup I've got in my lab too that I like to put a lot of stuff. I mean, I've got all the InfluxDB, right, React stuff all figured out. And I mean, the only problem with it, it doesn't support IPv6 at all, right? So you kind of need like an external load balancer to plug into it. So I'm kind of working on that piece too. So, but then it's like, how do you actually bring up traffic router in there?
Right.
Using a load balancer, how can you force the IP, right, for the external IP instead of having a traffic router to force it to.
Right, you have to use a server return or something like that if you want to use a load balancer.
Yeah, so it'd be nice to kind of figure it out because I'd like to be able to, well, if we actually want to run like, 4 traffic router but expose only one IP for it,
Right.
then we can load balance in between. And actually this could solve like a rollback and all that kind of stuff with like version. But, okay,
Yeah, I've only seen that with hardware load balancers. I don't know what's available in the software space to do that.
so, okay.
But I think you can.
No, it wouldn't
do
be server. Well, it's server return. Yeah, I get it. But the things I need the NS record. I need to be able to manipulate this to be the external IP of the load balancer.
Right. Yeah, so that would require some changes too.
Yeah, it's like making it. I mean, once we fix this piece, we can actually make this work with Ncast as well.
Think about that a little bit.
Yeah.
I don't think it would be. I need to think about that.
And it's
I think
also.
you could probably hack it so it would work right
Yeah.
now, I think, but it might be a little messy in terms of like CR config and traffic ops config and stuff like that. But
Yeah.
I think you could do it.
Yeah. So I'd like to map like IP to IP inside for like port 80, 443, and 53, I guess, right? But
Yeah, so the Anycast stuff that we've been looking at Comcast, I think, will kind of overlap with what you're trying to do there. I think we need to do that like on delivery services as well.
Yeah.
But if we wanted to do Anycast traffic router, it's the same exact problem.
yeah, because we have like the A record for.
Not same exact, it's similar.
Yeah.
But yeah.
Okay. Cool.
Yeah, but you get the Malenfant Bob who's driving his production. It's another another hack in there.
Which production? The lab production or production?
Your production.
Yeah. All right.